Hello everyone, and welcome back. So this time we're going to learn how to do the projection of a vector onto just any particular line you want using the dot product. Remember, projection, we're kind of talking about like a shadow there. A shadow of that vector on this other line. So, how do we do it? Well, first off, we have to draw our problem. So we have some line A. So this is the important detail. I might have two vectors like this. Here's A and here's B. And so what's the projection of A on B? I'm not saying, well, okay, when you look at this guy right here and how much of it does it cover? 100%. No, I'm saying, well, there's a line along the same path as B. Well, then the shadow falls along this entire section of the line. That's what I'm saying, okay? So don't get it confused. The vectors can be different lengths. You can have a bigger vector going over a smaller vector, or a smaller vector going over a big vector. It's just saying if I use that vector I have otherwise to draw a line, a big infinitely long line, what section of that line, how long of a section of that line has a shadow from the vector I care about. Okay, so to do this, well, you can see already that we have our vector A, and we have this line right here. We want to figure out these two components, the perpendicular component and the parallel component. Now, if we knew the angle between them, where have we learned about how to do angles? It seems so familiar. Oh, wait, dot product. If we knew the angle between them, it'd be fairly easy. We know what the direction of this line is. We can just use the unit vector, and then we could have the component in that particular section. Not too hard. So that is actually the very first step. For any case where you have two vectors, you want to find the projection of one vector on the other, you need to find the unit vector of the one that's going to become the line. Whichever one is going to become the line, whichever one is going to be projected on, that one needs to become a unit vector. And then you take the dot product of those two. You take the dot product of those two, and you get this point right here. Okay, so I'm taking the dot product. Okay, sounds good so far. But how is this going to solve this? Well, let's go to the next slide and see if it helps us out a little bit. See if we can figure it out. It actually doesn't do it to my satisfaction. So I'm going to go back here for a moment and talk about this just a little bit more. So remember that the dot product between two vectors is going to be equal to, I'm going to say A dot B is equal to magnitude of A, magnitude of B, cosine of the angle between them. Okay. Second thing to remember is this. The magnitude of the unit vector is always equal to 1. So that means if we have A, so B right here, that would have been our unit vector. So go ahead and write it here. A dot UA, you should have used a different letter. UA is going to be A times 1 cosine theta. Now are you noticing here what we're seeing? This is a cosine theta. That's the component. There it is. So that's why you're taking the dot product. That's what's happening there. It's just an awesome little identity from the dot product. Okay, so having done that, we learned that the parallel component is going to simply be what we just solved for times our unit vector along that line. And in the perpendicular component, we can just simply use the fact that it's a right triangle and do the whole c squared is equal to a squared plus b squared. And you're probably thinking, wait a second, there's a minus sign. That's because these are the components and this is the hypotenuse. And so we had to solve for it. It's kind of like we solved for A and now we want B, and so we have to rewrite it. So it would be b squared is equal to c squared minus a squared. So it's right there. It's the same exact thing as we had previously. And if we want to, once we're done with the vector, is we can actually add it all together. And we should see that if we add these two vectors together, we get our original vector back. If you don't, minus some slight decimal values due to rounding errors, you've done something wrong. You need to go back and check it. Okay, so hopefully this makes sense. Remember, you take the dot product between the unit vector of the line you're projecting onto with the vector that you care about. And that will give you the component that is parallel, that is projected on the line you care about. And then if you multiply that by your unit vector, you get the parallel component, the vector component of the parallel section. So if you get that, then you can solve for the perpendicular component. And we're all doing that using the dot product. So please match the dot product is incredibly important. And we'll practice with that some in a couple examples. Well, I hope this helps you. And I'll see all of you next time. Bye-bye.